Hey guys! Today we are going to build a stateful chatbot or a chatbot with memory. This kind of chatbot will be remembering our previous conversations that we made. For example, when I say my name is Uygar and I ask what is my name, this LLM will be able to answer accordingly. I am leaving a sample example here that we will do together. I also suggest you to check out Instruct Tuning Llama video, which I will put a link here. It is the main components to create an LLM, and I will be referring to that video from time to time. For this, we will be using Hugging Face's open LLM models, and we will use a Llama chat model. Most of the tutorials on this were using OpenAI's API, but that is not open source and that is a paid service. So I prefer this over that. You will learn how to use this Hugging Face LLMs with Langchain. The overall structure of the video will be, I will be talking about three types of memories. First one is a regular memory, where we give the all history to the model, and the other two types of memories are windowed memory, which instead of giving the whole context all history to the LLM, we will just give the last K conversation, so that we will be not using huge amounts of memory in case of a long conversation. And the second one is summary memory, which we will give the whole conversation as a summary to the input. So these are the ones that I chose. However, there are lots of more examples in the Langchain's website. As you can see here, I will provide a link too. If you want to go check out other types of memories, you are welcome. And before we begin, as always, make sure you smash that like button, subscribe to my channel, just do some comments, even it is for the algorithm. And if you are ready, let's just dive into it. We want to start with installing the necessary libraries. We can do it by, if you're in a cloud notebook like this one, you can do it like pip3 install. We are going to need Langchain. We are going to need transformers. In this case, I used this version, but other versions will probably work too. We will need bits and bytes, accelerate, and xformers. We hit enter and we wait for it to load. Now the library installations are complete. Beware that this may take a while. Okay, be patient. In the end, you may see errors like this. You may or you may not. So don't worry about it. Okay, it's fine. You can just ignore them. Now, since we installed the libraries, what we want to do is, we want to use them, right? For that, we are going to import them. Since we are going to use the LLMs from Hugging Face, we have to import the decoding libraries from the Langchain. In this case, we will import Hugging Face pipeline from Langchain community LLMs.huggingface pipeline. After importing this, we will continue with several imports from transformers. The model we are going to use is Llama. Okay, for this it is my choice. You can use Mistral, which is pretty hot now, or other LLM of your choice. I decided on Llama, so I'm going to import Llama Tokenizer fast to load the Tokenizer, Llama for casual LM to load the model itself, pipeline to put it into a pipeline, bits and bytes config to apply model quantization. Without that, the process itself may take a lot of resources. That out of the way, we are going to import something called prompt template. What this does is that, so the Langchain has a predefined prompt that it gives it for you. But if you want to give it your own prompt, we have to use something called prompt template. Okay, we don't have to use, but it makes your life easier. So I'm going to show you that too. Afterwards, we will need two chains from Langchain.chain. First is conversation chain, and the second one is LLM chain. In our case, in our use case, which is memory with chatbot, they act very similar. Okay, the only difference will be one of them will accept this prompt template and the other one won't accept it. Okay, there's just slight difference in our use case. After that, we will import something called conversation buffer memory from Langchain.memory. As the name suggests, this will be our memory for our chatbot. Lastly, we will import torch and we will hit enter. Now the importing has completed. I will specify the model name so that we can just use it from this variable. In my case, I am using this model, okay, Llama 27B chat model from Noise Research. I may have pronounced it incorrect, but you get the idea. You can use the one from Meta too. It's up to you. It's a preference. Like I said, you can use another model too. for example, Mistral or something like that. But in this case, the 7B version, small and easy to use, works for me. Before loading the model, we want to apply a quantization. So the reason for that is this LLMs are big models, okay, and we want them to fit into our GPU, and we want them to be fast and memory efficient. One of the best ways to do that, and easiest ways, is to apply quantization, and which is very easy to do. What we do is that we find bits and bytes config, and we give some variables. The first one is I want this model to be loaded in 4 bits, so I set this to true. After that, we specify the BNB, which is bits and bytes, quant type for this 4-bit quantization. In this case, it is NF4. I set it to that. We set it to computation D type. This is a data type. In this case, I set it to torch bfloat 16. Lastly, we have the option of BNB 4-bit use double quant. So some people prefer it, some people don't. It gives a slight more quantization. It's like it quantizes the model 2 times, something like that. It is a preference, but I decided to keep it as true. So we can run the cell. Now we can move on to load our model and our tokenizer. We load our tokenizer with Llama Tokenizer fast that we imported from pre-trained, and we give the model path that we defined here. After that, we load our model with Llama for casual LM that from pre-trained, same thing, we give the model. The only difference is, since we applied this quantization here, we give it as a variable. So quantization config equals to quant config, and we hit enter. It may take some time to load the model. Okay, so as you can see, it is downloading, so be patient. Loading and downloading the model and the tokenizer is complete. Now we have to put them into work. How we are going to do this is, for this specific case, we are going to define a pipeline, because for Langchain, we specified that we will provide it with a pipeline. Our task is simply text generation. This is how this kind of LLMs work, okay? It just predicts the next token. We specify the model we are going to use, which the model we downloaded. Same for the tokenizer. We set it to max new tokens, the maximum number of new tokens it can generate, and it continues with the number of beams equals to 10, early stopping equals to 2, no repeat engram size equals to 2. So what these are decoding strategies. I discussed a bit about them in my instruct tuning llama video too. So this is a way that the model generates text. You can think like that. However, it is out of the scope of this video to go into detail. However, there's a great blog post from Huggingface, which you can see here. I will put the link for that too. Just go there and check it out. For my case, this just worked fine. However, don't hesitate to experiment with different ones. As last, we define our LLM. We call LLM equals to Huggingface pipeline, which we imported from Langchain. And we just specify the pipeline equals to pipe. And this will be our LLM that we are going to use in association with the Langchain. This was the most crucial part, probably. So let's run this. The thing I like about this is when you look at examples with Langchain, it is usually using an OpenAI API. However, it is not open source, okay, and it is not free. Everyone may not want to use that. However, we have an access to other open LLMs with this. So this is pretty powerful. Now we have the pipeline. Let's first test it as a stateless chatbot. What it is that we will just give it a prompt and it will give us an answer and it will not remember anything about the past. So let's test with that and see if it actually works. We start by defining a template. In this case, our template will look like this. This is our system prompt. This denotes the end of system prompt. And this will be the instruction that we will insert here. This is a specific template I'm using because this is probably how this specific version of Llama trained with this format. However, there may be different formats depending on your specific model. If you want to learn about this, what are the differences between different prompts, whether you can use your own prompt or not, again, I suggest you check my Instruct Tune Llama video that I mentioned previously dozens of times. Okay, just go check that out. As an instruction, we will give what is your name. Okay, this is a simple instruction. After that, we will use prompt templates. What it is that we give the template here, which is this, is a variable, and we give input variables. So what it does, what it says is that we have a variable called this and put our instruction in here. Okay, it is like Jinja template. Okay, I guess that was its name. And we say format, we use the same name here, input variable, inst here, and specify its value. In this case, it is what is your name. Okay, you can just delete this too, okay, because we typed it manually. Okay, this is our instruction, what is your name? This will go to here, and we specified it in this input variable. The prompt template works like this. And how we get the result is that, as you remember, we have this LLM variable here, we define with Huggingface pipeline. We basically give the prompt to it as a variable, and it will give us the answer. So let's hit enter. Now let's continue with actually putting the memory to our chatbot through Langchain. So this will be the regular memory, okay, so it will just store everything in its memory. This is the most basic version. Here I will show you both how to do it with template and without a template using Langchain's default one. They both are important to know. So let's start with working with a template. So let's define our template here, and this is good to understand how the memory actually works under the hood. So let's just put our template here and go over it. So how it works is that as a regular template, we have this start system, end system, and this is our system prompt. Okay, I made it up. You are an AI having a conversation with a human. Provide as much information as possible. And now, how we give a memory to a chatbot is that we just put all the previous conversations here in this variable, in this chatbot. Remember that we did previously here, we inserted instruction to inst. Just like that, just like a Jinja template, we will insert the whole chat history into this variable. So when the model is going over this template, it will actually see the chat history and it will learn it again and answer accordingly, because the history will be in its input, so it will have access to that. Pretty simple idea, right? And it works great. After this, just we did previously, we say prompt template, that from template, we just say template, okay? So this will be our prompt. After this, we will define our memory. This, like I said, is a regular memory, so we will store everything. What we say is conversation buffer memory, and we specify a memory key. What is that is we give the name of the variable that the memory or the previous conversation will be inserted. I set chat history here to memory key. So this conversation buffer memory will take all previous conversation and insert it to here, which we are going to see just in a second. After this, we will start to define our LLM chain. So we say LLM chain, we specify our LLM as LLM we defined previously as a pipeline. We give our prompt, which is just prompt, and we say verbose equals to true. What it does is that it will just show what's going on behind the scenes, and we will just understand it better in that way. We will give memory equals to memory here and close it. Let's just run this. Conversation is loaded. This guy will be our chatbot. We will talk through that. So let's get to the talking part. What we do for talking is that we say conversation and we give it a dictionary denoting variables that we want to insert. In this case, I want to insert a question, which is here, okay? If this is a question, this has to be a question too. These names must be the same, because it will go to this dictionary, see, this is a question, so I need to insert it here, the one with question, like we mentioned, just like a Jinja template. After this, the chatbot will take all this prompt with inserted chat history, which we did here, and the question, which we give here, and generate us output. And we just store that into the conres variable. After this, let's just print the answer. Answer is conres. The main answer comes, in this case, in text field. It comes with several other fields like history and stuff. In this case, we just need the final answer. So I will just take the text field and print the answer. We don't stop here, of course. This is a chatbot and it is a memory, so we keep talking. So it will give us an answer, and we will say, from now on, I will call you John, okay? We say that your name is John from now on. So we expect the bot to remember that after this. We print the answer again, and we will check if it actually remembers or not. For that, we will ask, what is your name? And if it answers according to information we have given previously, it means that yes, it has a memory and it remembers its name. And let's just print that too. Let's run the cell. Depending on your GPU and your machine, it may take a while to generate the text. Once it is done, let's meet here again and analyze the output. The text generation is complete. Now let's just go over the whole output and see what's going on. We can see several things here. First is it says entering new LLM chain, don't care about it. Prompt after formatting. Okay, this is important. This green field is the prompt that we give to the language model. So the language model will see this green area, which is the prompt we defined here, and answer accordingly. Yet it doesn't have a previous conversation because this is only the first question asked, so it is blank. And as a first one, there is the question that we have inserted. Do you have a name? And the answer is, like we printed here, from the result of the conversation, is, yes, my name is Llama. I'm a large language model trained by a team of researchers at Google. My purpose is blah, blah, blah. So this is good. All right. Now it comes the part that we are interested in. Now we are moving on to the second prompt, second instruction. Again, we see to the prompt after formatting. By the way, we can see these prompt after formatting and finish chain and whatever because we set verbose equals to true. When we set that, it just shows us what's going on under the hood. Okay, so it is good to understand what's going on with, like, it's good to understand what's going on. Now let's look at the second one. As usual, we have our regular prompt, system prompt. However, in this case, there's a previous conversation and it is not empty. The previous conversation is, do you have a name? AI, yes, my name is Llama, and it goes like that. It is just the previous conversation with it. So we feed that to the model too in this case. After that, we put our question here. From now on, I will call you John. We say that your name is John, basically. Okay. And the model answer it as, I see, John, it is Dan. How may I assist you today? So it acknowledged his new name, John. Now let's test if actually it remembers or not. Again, prompt after formatting, system prompts, and the previous conversation. Now we have the part where we say your name is John too. Okay, so we give that as a previous conversation. And since this is the whole prompt, model has access to it now. Our question is inserted here. What is your name? Like this here, okay? And the answer is, a simple question, yet one that I must provide, blah, 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 illusion, blah, blah, blah. However, if you insist on blah, 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 you may refer to me as John as you previously requested. So from this here, we can see that it actually accessed the previous conversation that we fed here. And here we set its name and it actually refers to that, remembers that, and says, yes, you can refer to me as John as you previously requested. So that was the main idea and the thing that we want to accomplish. Now we have a clear understanding of how we put the memory into the model and how it works. Let's do it without our own prompt and just use the Langchain's default prompt, which we are going to continue with that from now on. For this, instead of LLM chain, we will say conversation chain. We will give LLM as usual. We will say verbose true because I want to show you what's going on under the hood again. We give the memory, which is conversation buffer memory, and that's all. Let's run this. And our chatbot is ready to be used. I'm going to use the same exact conversation as before, so I just copied and pasted from above, okay? But however, there are a couple of slight changes here. One change is that instead of question, since we are using the Langchain's default prompt, I replaced it with input, because under the hood, they use input instead of question. So they will insert this into the input field. So this became input, and the conversation res, instead of taking the text, we will take the response field. Okay, the text became response. Just those two tiny differences, and we can just run it again as previously. Now the text generation is complete. Let's skim through the outputs again. First, again, as usual, we have the prompt, the part that we feed into the model as green. It is printed because we set variables to true. First thing we notice is that prompt is different, okay, from us, because this is the default prompt provided by Langchain. The following is a friendly conversation between a human, blah, blah, blah. This is the system prompt. Current conversation is this, empty, okay, we don't have anything yet. We just ask this here. So in the default prompt, it doesn't have a previous conversation, but it puts everything under the current conversation. So the first thing that we see is answer from the chatbot is different, okay? In the previous case with the template, it was, I'm Llama, I created that Google, blah, blah, blah. Now it is like, oh, wow, I'm so glad, adjust glasses and some things like that. The difference is because of this prompting format. Okay, as you can see, the way you prompt, it can create a huge difference. That's why I showed you how to create your custom prompts, at least one of the reasons. It goes like this, it puts the previous conversation here. We said, from now on, I will call you John. After that, it says, raises eyebrow, interesting choice, is a unique name, blah, 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 and answer. At last, we ask, what is your name? Okay, we expect it to remember it because we provided it as a history. It answers like pauses, looking thoughtful, and blah, 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 more blah, blah, blah. But I much prefer to be called John. It suits me better, giggles. Okay, so just like we said that your name is John, we provided as a history here, as a memory, and it remembers that. Like I mentioned, from now on, like this, we will use the custom prompt. We will use the Langchain's default prompt because it is easier to work with. But if you don't like the default prompt, you can change it as I mentioned previously. As a side note, one of the things that I like Langchain about is that it's garbage collection. We did all these things on GPU. Regularly, we would need to empty the cache of the torch and free up GPU memory and stuff like that, but Langchain takes care of that for you. And as you can see, we still have 0% GPU use after the execution is complete. So we went over the regular memory. However, it has a major setback. Can you guess what it is? Let me tell you. If this conversation, the previous conversation, for example this one, goes too long, okay, let's say maybe 40 or 50 prompts, and if we give that 50 prompt conversation as inputs, it will be a huge memory consumption for the LLM. The longer this input, the number of tokens in this input grows, the more memory and the resources we will be using. And after a while, it will become unfeasible to use that memory anymore. Because at a certain point, it will grow so much that we will run out of memory and we will not be able to generate the outputs, and it will take a lot of time. There are several approaches, intuitive approaches to overcome that. However, my favorite two ones are windowed memory and the summary memory. Okay, now we will talk them about both. However, the first thing we want to do is go to the import part, because I missed two imports here. Put conversation buffer window memory and conversation summary memory into import from Langchain memory. Okay, these two were not here, I just put them now. That out of the way, let's just move into the window memory. How window memory works is that we will define a window that the language model can look into. For example, we will say the language model that you will only have access to the last two prompts and the other will be deleted. So at every time, if we set the window size to 2, the language model will look into the 2 previous prompts and give the answer accordingly. And we will not have to store the previous ones. And by this, we will be solving the memory issue. However, we will be losing the previous information too. So there's a trade-off. Now let's look at how we can use the window memory and do some experiments with it. As usual, we define our conversation with conversation chain. After that, we set the LLM to LLM. We will say verbals equals to true because we want to see what's going on. Now we set the memory. The memory here is conversation buffer window memory. That's how we basically activate the window memory, and the K is the window size. For example, I set to 2 here, so the model will be able to see the true prompts previously and give the answer to us accordingly. You can set it however you like, depending on your available resources. And we just close it. This is how we define the conversation. And we run it. Now we have to test if it works or not. Here, I gave a conversation to the chatbot. Okay, the conversation is input we ask, from now on I will call you John. Again, we tell that your name is John basically. And after that, we ask 2 placeholder questions, like what is 2 plus 2 and where is Spain. In last, when we ask what is your name, it will go to since we set the window size to, it will be able to see only these 2 prompts and answers. Hence, the model will not be able to access this first prompt, from now on I will call you John part, and will not be able to answer our question, what is your name? Even though it won't be answered to that question, we will save a lot of memory throughout the way. So let's just run this. Now our run is complete. Let's look at the logs. First, as usual, we will have a prompt and we will have the question, from now on I will call you John. The model answers as, a new name, chuckles, blah blah blah, I like blah blah blah. Now we still have the John part in the conversation, and we ask what is 2 plus 2. It answers to our question as 4, okay? And after that, we still have these 2 conversations here, which we call him John, and what is 2 plus 2. In this part, we add a new placeholder question, where is Spain? It answers as excited, or that's, wow, what a great question. Spain is actually a country located in southwestern Europe and continues like that. Now, when we continue and see the current conversation for our last question, which is what is your name, we can see that the first part is disappeared. The part where we told the model his name, which is John. As you can see, it starts with what is 2 plus 2, and this part is missing, okay? Because we used memory with window, and we set the window size too. So it only has access to the last 2 windows, which is, this is one window, and this is the second window, okay? These are the last 2 windows it has access to. So when we ask what is your name, it will not say John because it doesn't know that. It just answers, I'm glad you asked, my name is Ada. Okay, so it is not John. This is how window memory works. And it is a great way to shorten the whole chat memory into just K recent ones. The last type of memory I'm going to show you is the summary memory. So what summary memory does is that it takes all of your previous conversation, for example this one, okay, and using another LLM, it summarizes it and gives it as the previous conversation. It is very intuitive. However, in my current condition, I don't have enough memory resources, so when I run it, it crashes. However, I will show you how it is done, and you can just use it on your own. How we do it is, we will use conversation summary buffer memory. We will, again, put our LLMs here, and we will put max token limit here. You can specify that according to your needs. After that, we just, as usual, define our conversation with conversation chain. We put our LLM as LLM. We say variables equals to true if you want to see what's going on behind the scenes. We put our memory, and that's it. A little note here. In this case, if you realized we did something different with the memory. Here we have conversation summary buffer memory, but we passed an LLM to it. We passed an LLM to it because this summarization itself will be done by an LLM, okay? So in the background, it takes all the information, all the previous conversation, and summarizes that with another large language model. A quick idea here, for example, in this case, for summary, we are using the LLM again. In this case, Llama, we are using Llama. But more smaller models can do the summarization too. For example, T5, okay, it is a smaller model and it can summarize things. If you want to be more memory efficient, I suggest don't use Llama here. Instead of use a smaller model for summarization. But now let's just continue like this, run this. Now let's put it to actual conversation. I put a long text as a placeholder again. You can make it long, okay? As 3 dots, I meant that it is a long text. After that, we say memory.save context. This is new. What it does is that it saves this chat into the history. So this is just to speed things up. And another save context, hello, output is what's up, input fine you, output nice, what are our tasks for today, and the output is this guy, this long text. So what we're trying to achieve is that put lots of text into the previous conversation memory and see the summary in action. After this one, we just say conversation input. Did you have any meetings today, for example, and take the tasks. It will give you the output with summary memory. However, I won't run it because it is too much for my current GPU, it crashes. However, if you have a stronger GPU, you can run this and see it in action. To end things, we covered regular memory, which we put the whole previous conversations into the input to our LLM. We mentioned that when the chat goes longer, it may cause memory problems. So we took a look at the 2 common approaches, which is windowed memory and the summary memory. In the window memory, we define a window and the LLM just sees that window. In the summary memory, another LLM summarizes the whole conversation and puts that summarization as input to the model. Of course, there are other approaches. I suggest you go to the Langchain's website and see this web page and just check those documentations out. However, for this video, I just showed you these 2, I think, intuitive ways. And sadly, this is the end of another video. If you like that, just make sure you subscribe to the video, like it, and comment and stuff like that. Hope to see you at another video. Goodbye.